This is lesson 13, module 5, problem set, page S69. This wants us to determine the volume of the rectangular prism. And you can see that it gives us the area of this front face. So the area is the length, the width, and the height. So this area actually is, they already did it for you. They calculated the length times the height. So this is the L times the H, and we have to combine it with the W. So we're going to do area equals length times width times height. They combined the length and the height, so we already know that, and they gave us the width. So the area would equal 30/7 times 1/3. I'm going to multiply right across, which is 30 over 21. I can reduce these by 3, which would give me 10/7. This is an improper fraction, so we're going to say 10/7 centimeters cubed, or 7 goes into 10 one time with 3 left over, and 7, as our denominator stays the same. So the volume, I'm sorry, this shouldn't even be A up here, it should be V. The volume equals 1 3/7. Number 2, it wants us to determine the volume of a rectangular prism in problem 1 if the height is quadrupled multiplied by 4. Then determine the relationship between the volumes in problem 1 in this prism. So if the if the height was quadrupled, then the whole volume would be quadrupled. So I'm going to quadruple this. So quadruple means times 4, so 10/7 times 4, to make a whole number fraction, you put a 1 under it, which is 40/7, or 7 goes into 40 5 times, which is 35, with 5 left over, and denominator stays the same. So there's the volume. 5 5/7 centimeters cubed. Number 3. So it says the area of the base of a rectangular prism can be represented by B, and the height is represented by H. Write an equation that represents the volume of the prism. Okay, so 3A is going to be V equals base times height, because the base includes the length and the width. If the area of the base is doubled, write an equation that represents the volume. Okay, the area of the base is doubled, so we're going to say 2BH. If the height of the prism is doubled, write an equation. B equals B, and the height is doubled. Or, we know that that's not standard form, so 2BH. It would be the same. Compare the parts of B and C. What do you notice? Okay, so I'm just going to say, to prove it, I'm just going to say B equals 1 and H equals 2. If I used the first one, 2BH, and compared it to the second one, equals B 2H, and B always equals 1, I'm going to substitute 2 in, and H equals 2. Okay, B equals 1, and H equals 2. These are the same. I'm going to get the same answer. So, compare the volumes. What do you notice? They are the same. Or they are, let's use a math word, they are equal. Write an expression for the volume of a prism if the height and the base area of the base is doubled, are doubled. Okay, so we're going to say V equals 2B 2H, like terms right here. So 2 times 2 is 4, so it would be V equals 4BH, and that was 3E. Number 4, it wants us to determine the volume of a cube with a side length of 5 1/3. So I'm going to draw my cube. Cube is a three-dimensional square. All equal sides, all equal angles. So 5 1/3, 5 1/3, 5 1/3. The length is 5 1/3, the width is 5 1/3, the height is 5 1/3. Change these into improper fractions. So 16 thirds times 16 thirds times 16 thirds. 3 times 3 times 3, 3 times 3 is 9, times 3 is 27, and I am going to need to use my calculator for that next one. 4,496. So I need to change this into a mixed number because it is improper. So I'm going to think about how many times 27 goes into 490, and I don't know, so I'm going to have to divide on the side. Not 490, I keep saying 490, 4,096. So 4,096 divided by 27. Okay, so it can't go in that, it can go in once, which is 27. 13, bring down the 9, 27 can go into 139, 5 times, which is 600, oh wait, not 5 times, not 5 times, what am I doing, How many times can 27 go into 139? Yeah, I can. 5 times. 135. Which is 4. Bring down the 6. 27 can go into 46. I'm going to say 2 times. Maybe that's a little too much. It is too much. So it can only go in once, which is 27. 19. You would be correct if you wrote this answer, but to just take it to the next step, it would be 151 and 19 over 27. And what are we working with? We are working with inches. Inches cubed equals the volume. Okay, now number 5. Use the information in problem 4 to answer the following. Determine the volume of the cube in problem 4 if all the side lengths are cut in half. How could you determine the volume of the cube of the side lengths cut in half using the volume in problem 4? Well, if they're cut in half, then all I would have to do is I would have to cut each one in half, so I would have to divide this by 2. So 5 1/3, which I know is 16 thirds, divided by 2 over 1. Keep switch flip. 1 and 8, which is 8 thirds. So to figure that one out, 8 thirds times 8 thirds times 8 thirds. And 8 times 8 times 8, I better use 64 times 8, 8 times 8 times 8, it's 512, 27. And I'm going to leave it up there at that. And we're not working with centimeters, inches, cubed would be the volume. Okay, that was lesson 13.